Welcome. This video is about matrix multiplication, how one matrix can be multiplied by another matrix. So that's what I'm going to talk about next. So before proceeding to the multiplication of matrices, you have to check, are matrices comfortable for multiplication? Or in other words, can the two matrices be multiplied at all? So this check is important because it determines whether it is possible or not. So how to make this check? It's very simple. Just count the number of columns in the first matrix and the number of rows in the second matrix. And if they are equal, it means that the two matrices can be multiplied, otherwise not. So let's take an example how this works. So the condition is that number of columns in the first matrix must be equal to the number of rows in second matrix. If this condition is satisfied, the multiplication can be performed, otherwise not. So here we have the matrix A, which is a column matrix, and matrix B, which is a square matrix. The order of matrix A is 3 by 1 because it has 3 rows and 1 column, and the order of matrix B is 3 by 3 because it has 3 rows and 3 columns. So as the number of columns in A is not equal to the number of rows in B, that is 1 is not equal to 3, therefore the multiplication AB is not possible because here the condition is not satisfied. But is multiplication BA possible? So yes, it is possible because the number of columns in B, which are 3, is equal to the number of rows in A, which are 3. So as 3 is equal to 3, therefore the multiplication B is possible, but the multiplication AB is not possible. On the next slide, there is an example where AB and BA both are possible. So in this case, the matrix A is a 2 by 3 order matrix because it has 2 rows and 3 columns, and the matrix B is a 3 by 2 order matrix because it has 3 rows and 2 columns. So the multiplication AB is possible in this case because the number of columns in A is equal to the number of rows in B, and similarly the multiplication BA is also possible because the number of columns in B is equal to the number of rows in A. So in this case, the multiplication AB and BA both are possible. So you have to check. So you have to make that check in order to know whether it is possible or not. So the question that arises here is that what is the order of the resultant matrix in both of these cases? So here is a shortcut method that will help you to determine the order of the resultant matrix. So in the case of AB, we know that the order of A is 2 by 3 matrix, which is multiplied by matrix B, whose order is 3 by 2. Here the inner numbers indicates that whether matrix multiplication is possible or not. If they are same, it means it is possible. So in this case, 3 and 3, so it's same. So these two numbers are same, which means it's possible. But the outer term or the extreme terms, which are 2, 2, that actually represent the order of the resultant matrix AB, which is 2 by 2 in this case. So the order of AB is 2 by 2. Similarly for BA, we know that the order of B is 3 by 2, which is multiplied with the A, whose order is 2 by 3. So the inner numbers are 2, 2, which are same, which means the matrix multiplication is possible, and the outer terms, which are 3, 3, that represent its order, and it is 3 by 3 in this case. So the order of matrix B multiplied by A is equal to 3 by 3. So that's how you can find the order of a resultant matrix. So now coming to the main topic, which is the multiplication of a 3 by 3 matrices. So in this case, the matrix A is a 3 by 3 matrix, and the matrix B is also 3 by 3 matrix. So using that shortcut method we just discussed, the matrix multiplication AB is possible, and the order of the resultant matrix will be 3 by 3. So now coming to the method which can be followed to multiply these two matrices. So the method is, first you have to multiply the first row of the matrix A by the first column matrix B, then by the second column matrix B, and then by the third column matrix B. When you are finished with the first row of matrix A, you have to come to the second row of matrix A. So multiplying that second row by the first column matrix B, then by the second column matrix B, and then by the third column matrix B. When you are finished with the second row, you have to come to the third row of matrix A, which in this case is the last row. So multiplying that last row or third row by the first column matrix B, then by the second column matrix B, and then by the third column matrix B. So that's the whole procedure that can be followed in matrix multiplication. So let's begin and start multiplying the first row of matrix A by the first column matrix B. So the first row is 0, 1, 9, and the first column of matrix B is 1, 3, 2. That is equal to 0 times 1 plus 1 times 3 plus 9 times 1. What we did is that we multiplied the first row and the first column element wise. So multiplying and adding them together, we get 21. So this elemental value, what will be its position in the resultant matrix? So its position will be 1, 1. That is first row and first column. And the reason is that we have multiplied the first row of matrix A with the first column matrix B. Therefore, its position will be 1, 1, first row and first column. So inserting this 21 value in its position. Now multiplying the first row with the second column of matrix B. So 0, 1, 9 multiplied by 3, 1, 4. So carrying out the element wise multiplication, that is equal to 0 times 3 plus 1 times 1 plus 9 times 4, and that is equal to 37. So what will be its position? Its position will be 1, 2, that is first row and second column. For the same reason that because we have multiplied the first row with the second column. So putting 37 at its position. Now multiplying the first row with the third column, that is 0, 1, 9 multiplied by 7, 0, 1, and that is equal to 0 times 7 plus 1 times 0 plus 9 times 1. So adding them and multiplying them, we get 9. So we are done with the first row of matrix A. Now we start multiplying the second row of matrix A with the first column, then with the second column, and then with the third column. So now multiplying the second row of matrix A by the first column matrix B, that is 3, 1, 5 multiplied by 1, 3, 2. So carrying out that element wise multiplication, that is equal to 3 times 1 plus 1 times 3 plus 5 times 2 is equal to 16. So what will be its position? Its position will be second row first column, because we have multiplied the second row of matrix A by the first column matrix B. So inserting this 16 value at its position. Now multiplying the second row by the second column. So 3, 1, 5 multiplied by 3, 1, 4 is equal to 3 times 3 plus 1 times 1 plus 5 times 4 is equal to 30. So its position will be 2, 2. So now multiplying the second row by a third column, 3, 1, 5 multiplied by 7, 0, 1 is equal to 3 times 7 plus 1 times 0 plus 5 times 1 is equal to 26. And its position will be 2, 3, because second row and third column are multiplied. Now third row of matrix A and multiplying it by first column, second column, and third column. So multiplying third row by the first column, that is 2, 1, 7 multiplied by 1, 3, 2 is equal to 2 times 1 plus 1 times 3 plus 7 times 2 is equal to 19. And its position will be 3, 1, that is third column and first row. So putting 19 at position 3, 1. Now multiplying third row by second column, that is 2, 1, 7 multiplied by 3, 1, 4 is equal to 2 times 3 plus 1 times 1 plus 7 times 4 is equal to 35, and its position will be 3, 2, that is third row and second column. So putting 35 at its position. Finally multiplying third row by third column, that is 2, 1, 7 multiplied by 7, 0, 1 is equal to 2 times 7 plus 1 times 0 plus 7 times 1 is equal to 21, and putting it at final position, that is 3, 3. So the final matrix that comes out as a result of multiplication of matrix A and B, which are both 3 by 3 matrices, is 21, 37, 9, 16, 30, 26, 19, 35, 21, which is a 3 by 3 matrix. So that's how you multiply 3 by 3 matrices. So thank you guys for watching this video, and if the video helped you, give it a thumbs up, comment any question you might have, and subscribe for more.